without further ado, I would like to welcome our moderator, Amit Mahajan, for the first talk. Amit.
Hi, everyone. How's everyone doing? All right. I don't think there was enough caffeine in the coffee, but I can tell you, the next session will definitely wake you up. So we are here in San Diego talking AI. And, when we talk technology in San Diego, the first company that comes to mind is Qualcomm. So to kick off this conference today, our speaker is not only a top leader at Qualcomm, but also an IIT alum. So it's my great honor to introduce Dr. Durga Malladi, Senior Vice President and General Manager at Qualcomm, where he oversees technology product management and roadmap planning across all business units, including AI. In his prior roles, he's led pivotal roles at Qualcomm in 4G and 5G. He's hundreds of patents to his name, and he was recently also awarded the Distinguished Alumnus Award from his alma mater, IIT Madras. He holds a master's and PhD from UCLA. So we are looking forward to hearing his vision on AI today. Please welcome, without any further ado, Dr. Durga Malladi.
Okay, all right, so I have 20 minutes, and I was kind of thinking thanks to the organizers for actually inviting me here. So my job is to kick off and actually kind of hopefully give a sense of what the future of AI is. Mind you, this is a very fast-moving field, so it's kind of hard to predict what's going to happen 5 years from now. But I figured that the best way to think about what the future of AI is going to look like is to actually go back in time and start from where it started. So it's not a history lesson, and I'm not going to wow anyone in the audience because most of you already know this, but let me take a stab at it anyway. So it was summer of 1956. If you kind of remember the history of AI, at Dartmouth, there was McCarthy, Minsky, Rochester, and even Claude Shannon from Bell Labs back in the day was there. They were called thinking machines at that point in time. And the question was, what is this field going to be? There was information theory that was happening in the background, cybernetics and automata theory. But I think it was a politically correct way of actually calling it as artificial intelligence. That was the first time that artificial intelligence, the name was actually used. A lot of euphoria, this was in the 1950s, about what the overall goal should be, replacing or mimicking human brain behavior and whatnot. Multilayer perceptrons just started coming out at that point in time. And at some point, it was clear that they were running into a lot of limitations. Processing power was not there, data was not there, but the theory itself was kind of half-baked at that point in time. So while that initial euphoria died out, that was the first spring of AI. It led to the winter of AI in the 1960s. By the late 1960s, nobody really cared about AI as much. Things had moved on and other things. In the 1970s, most of the things were in the wilderness, but there is one thing, by the way. Jeff Hinton was a math professor at University back then he was a PhD student, and he did his postdoc, by the way, Dr. Khosla, you might know this, he did his PhD at UCSD, and backpropagation was actually invented in that area. There were a few others, but credit goes to him along with a few other professors at that time. So things were still moving along. In the early 1980s, then there was a new resurgence in interest in AI. Expert systems and bringing in the beginnings of convolutional networks. Not quite there, but it is the beginnings of it. And somehow even that didn't quite take out. I think we were still involving humans quite a bit into the loop, and it hadn't really taken off that much. So by the late 1980s, again, things fell apart. So that was the second winter of AI. In the early 90s, maybe just an anecdote, I came to the US in 1993. I just graduated from IIT Madras, joined UCLA. I was a fresh grad student just on my way towards PhD. And you know how it works. It's a large group, and one of the postdocs said, we have this nonlinear filtering problem. Maybe you should try neural networks. I was scrambling to say, okay, what this is. Worked on it. My first conference paper was on neural networks. But I had no idea why the hell it was working. And I still didn't get a good sense of things. And I remember going to my advisor at that point saying, there is no way I'll ever get a job in AI. He looked at me and he said, maybe you should try wireless. So I went off into wireless at that point in time. I spent the next few decades, a couple of decades at least, but I still had that in the back of my mind as to what else can be done because there's something to it. It was working. I just couldn't explain why it was the case. But there were two other interesting paradigms that actually went on, and that's the reason why I believe that we are in a much more, in a different state altogether today. It was the birth of the internet. What started off in wireline went off into wireless, which means we had tons and tons of data. That was observation number one. Second, processing power exploded dramatically. Actually, what we could do in the 90s compared to what you can do in a smartphone today, there's like no parallel whatsoever. So the third spring of AI, when it started off, I think the credit goes to something like AlexNet from 2012, when the first convolutional network came out, beat all the benchmarks on the image recognition problem that was out there. That was really like a massive resurgence after that, and we have not actually looked back since then. We are still in that, that was not generative AI, bear in mind, that was still classical AI, but there was something to it that made a difference. And 2018, if you remember, was the first time the Transformer paper came out, published by Google, 2018, 117 million parameters. That's it. Nobody paid attention except those in academia. 2019 was GPT-2, the second Transformer paper, 1.5 billion parameters. Today we can do most of that without breaking a sweat. It was November 30th of 2022, just 2 years back. For the first time, everyone heard the phrase Chat GPT. And anyone who's not even involved in AI was like, what is this thing? It seems to be working very well. 175 billion parameters, by the way. And that's what really led, I would say, the resurgence of commercial interest in addition to research into generative AI. The question is there going to be another winter of AI after this as we think about the future? TLDR version of that would be, my prediction is no, but let's actually go through a little more slides and then come back to it. By the way, my job is not to bore everyone with slides over here. I only have 3 more if you're counting. All right. If I just take a look at, first things first, what is the challenge over here with generative AI? There's plenty of studies recently that were done, but there was a Reuters paper that came out in early 2023, which actually simply looked at if every single person, let's say you're doing a search, let's just take Google search for example, and you have a certain prompt length, and all of that inference is running on the cloud, and the response is anywhere from 10 to 50 to 100 tokens. That's the response length. And the number of users scales up. So it's like a 3-dimensional scale, but what became very clear is even if the hardware costs keep coming down, it's simply not scalable. Now that was back in the day. Today we talk of multimodality with all kinds of modalities, not just text, but we're talking of voice, images, and video. If you want to search with voice and images and video, not just typing, it's a completely different kind of it simply cannot scale in the cloud. It becomes like a massive problem. By the way, some other studies have indicated that the total electricity consumption, because cloud servers are actually not as energy efficient as they could be, it can take up to 3.5% of the world's electricity consumption. That's a non-trivial number, actually, if you think about it. So we have to do something else. The good news is we do have a solution, and that's in network architecture. Typically, we talk of a distributed architecture, processing workloads that are split across the entire network, a combination of things running on devices somewhere at the edge and all the way into the deep cloud. One question, by the way, about 1.5 years to 2 years back when I would talk about it would be, why in the world do you want to run something on a device? You can just connect to the cloud and be done with it. Aren't you the guys who invented 5G or worked on it? So you have the connectivity all the time. The answer is not quite that. More and more users are interested in personalized AI. And what I mean by that is you and I, we might have same questions, but we provide our local context. I might take my phone as an example, point in a certain direction and say, what am I looking at? That question is meaningless unless I provide more information. Where are you? Which direction are you looking at? And so there's a lot of other information that needs to come in. It's best suited to do that if you can pull it off in a localized way right in the device itself. At the same time, there's a lot of training, foundational model training that can continue happening in the cloud. And somewhere in between, we can do enterprise-based processing. Both inference and fine-tuning. So these are certain trend lines that we see as far as the solution space is concerned. There's a couple of other things that are important. A lot of regulators, by the way, play a role in this. One of my worries is that we stifle a technology that is still at its very infant stage. What you don't want to do is kill that promise early on without fully understanding it. I think a lot of us in this room, I feel, have this job of making sure that the technology is well understood. It's not something to be feared, but it's to be embraced, and actually we move on. I hope that a lot of us actually share the same kind of a vision over here. Okay, now, what else is happening in this space? So remember I said that GPT-3 back in the day was 175 billion parameters. And if you take a typical phone today, and I'm just going to go a little bit into the commercial realities and come back again into where the future is. A typical phone today has a DRAM footprint of somewhere between 8 to 12 gigabytes. Okay, so if you take 175 billion parameters, most of the models are in float 16, 2 bytes, so you actually go up to 350 gigabytes, impossible to scale in a phone. But here's two things that are happening. First, state-of-the-art models today, 7 to 8 billion parameters, outperform just last year's GPT 3.5, which was at 175 billion parameters, which itself was outperforming the one before. It's not quite Moore's law, but there is something over here. The number of parameters are coming down dramatically, while the MMLU score remains the same, the language understanding benchmark scores that we talk of. Small models, SLMs, are becoming more and more sophisticated. Once you do compression and quantization of those models, you can actually make them run very efficiently in consumer IoT, industrial IoT, obviously in smartphones and compute and in XR devices. So that's actually a pretty good trend line as far as the ability to commercialize these models. But I believe that a lot of the research and the future of AI is going to be in terms of how do you extract the maximum out of it. There is an analogy with information theory back in the day. There's no notion of a capacity of a network. If you remember, from the 1920s to the 1950s, everyone was trying to do the best, but there was no notion of a capacity. But I still believe that there is some work to be done over there to figure out what can you extract at the maximum level. A flip side of that is by the time you get to implement, and this is a world like a lot of us live from a commercial perspective, is we are dealing with a lot of constraints, thermal constraints, power constraints, and not to mention memory constraints and memory bandwidth. So there's a lot of implications that come in devices. But what can we do today in devices? If you take a typical smartphone, you can run a 7 to 10 billion parameter model. Take Llama 8 v3.1, which is about 8 billion parameters. Yeah, without breaking a sweat. That's not a problem. By the time you compress and quantize it, it's just a small fraction of your overall DRAM footprint. By the time you get into the compute space, 10 to 33 billion parameters, automotive about 60 to 70 billion parameters. Automotive is not just about ADAS when it comes to generative AI. Picture the following. You're actually simply driving and you're just talking to your car and saying, can you reroute my, I want to actually go in this direction. The last thing you want to do is stop and muck around with everything over there. Voice is the natural UI as you move forwards. This is not about you actually typing in anything. Similarly, unfortunately, let's say you get a flat and now you stop the car. Instead of trying to figure out where the user manual is, what do I do next? Okay, back in the day, we all used to have user manuals inside the glove compartment. Now we have PDFs of those, but you still have to scroll through that. I don't care about the PDFs at this point. Just talk. Just tell me what it is, and we can go from there onwards. That's where things are heading. But voice is once again becoming a natural UI in terms of how the processing ought to be done. The third part is, just like humans, we don't just use our hands. We just don't text. We use a combination of sight, that's images and video, voice, and text. The three modalities are here to stay. They're not going back. In automotive sector, we have to add on top of that radar and LiDAR. But these are the modalities that are coming together with what are now emerging as end-to-end transformer networks. This is typically something that's coming up in automotive. But there's tons of work that's over here. So I'm pretty bullish and optimistic about where the future is. And as we go from here onwards, a small shout out to Qualcomm, not a big one. If you were to just say, okay, is this all real or is this just a PowerPoint presentation? The answer is no, it is real. You can actually go into a store today and buy a phone that runs generative AI. You can walk into Best Buy and get any of the 20 plus Copilot Plus PCs. By the way, Microsoft's definition of Copilot Plus is you can run generative AI on device, like on your laptop itself. Most laptops are, for productivity tools. This is for email creation, document summarization, translation from one kind of a document to the other. I look forward to the day when I can just talk to my PC and get things done. Instead of actually writing code, I'm going to actually suggest an algorithm and the code actually gets written. Maybe for the first time, I don't know how many different languages we've all learned over the years. For the first time, instead of us learning languages of the machines, maybe the machines should learn our language, the voice UI. That's the simplest way of actually thinking about it. In addition to these productivity tools, there's a lot of predictive AI, or it's also called as pervasive AI. That's the kind of a mentality that's coming in. Everything that I talked about earlier was on demand. I want something to be done, or you want something to be done. You prompt a question, you get an answer. Doesn't matter what the question is. But what if you had something that's constantly running in the background, anticipating your next move, thinking and reasoning on your behalf? That is a real co-pilot. In the commercial world, it means that we have a situation where, it's like constantly running, therefore it has to be like ultra low power because you have to just take it for granted. You can't have an impact on the battery life. Now, I wanted to show, there's not a demo, but there was just one picture over here, a multimodal model that's running on a device. And the reason I actually put it up over here is, by the way, incidentally, my dad himself is an IIT Kharagpur alumni. He's from 1960s. He did his bachelor's and master's from there. And he's a very tough nut. So when I was telling him about this, and he said, I don't think there's a whole lot of AI over here. I still see him seeing the same phone. I don't see anything different. My mom, who's a math major, and she taught math in high school all of her career, she then said, I'm not impressed either. So I was like, okay, this demo, by the way, we just did this in Mobile World Congress in Barcelona earlier this year, is a phone which you point at your kitchen table. There's like a bunch of vegetables out there. And you ask the question, create a recipe out of this, okay? First things first, if you break down the problem, it's voice. You're just saying that. You're not typing anything. When you say that, first you have to understand what is the question, okay? Second, there's an image classification problem. You have to figure out what all the different vegetables are. That's a convolutional network, for instance. You can actually figure out what the things are. So detection and classification. Then you have to understand that the question is about a recipe. The question is not what are those vegetables. And you have to, it's a generative AI. So you, on the fly, you're creating a recipe based upon something that it's been trained on. It's a really nice demo. And this was the first glimpse of, okay, my dad said, yeah, okay, that's not bad. And my mom was like, why would I need the phone to tell me what recipe it is? Separate story, but the point is made. I think we are reaching a point where we are beginning to use devices in a very different way. For the longest period of time, we've made smartphones so complex that I can bet that 90% of the people don't know all the things that it can do, let alone change the settings and whatnot. I gave a talk. This was a political event that was organized in DC. I spoke about it, a lot of regulators. Lena Khan was there by the way, from FTC. It was like a nice talk. And after everyone left, one nice elderly gentleman came up to me and said, thank you for this. And there was another person next to him, and I realized that he was visually impaired. He said, actually, for everyone who's visually impaired, the smartphone's revolution just went by and we couldn't do anything with it. But I can use my voice. If that can help me, that's a big difference. For the first time, I realized that, we all live in our bubbles. It's good to sometimes go outside and think about all the different problems that can really be solved. It's not just technology sometimes. We do some good in this world, and we tend to forget that sometimes. So bottom line, I hopefully gave you like a picture of what the future of AI could be, and looking forward to all the rest of the talks over here. Thanks for having me. I can start and take the questions. No problem.
So few questions. So guys, one thing we forgot to announce, we do have a Slido here. There's a code at the top. But since we did announce it there are also cards that are floating around where you can write questions. So for this one, we have a few questions that have come up.
Okay.
So the first one is, we all hear about job losses happening as Gen AI picks up and more automation is happening. So for this tech crowd over here, what are one or two learnings from the tech history that they can incorporate to enhance their careers in this fast-paced Gen AI world?
I think from an organizational standpoint in enterprises, a lot of us are in companies where the similar questions actually come in. I actually believe that everyone is capable of a lot more than the current job that they're doing. I think when they started off in their careers with all the background that they did, whether it's their bachelor's or master's degree or whatever it was, it's just a matter of retooling yourself and actually trying to pivot towards that thing. So the first thing would be a lot of the work, for instance, in Gen AI is based upon, there's a lot of probability theory, signal processing, a lot of things. These are like core things that people already know. So retooling the workforce, I believe, is extremely important. It also dispels the myth about job losses over there. It's actually about job translation from one kind of a job category to a different category. Look, every technology event, when it comes in, it always changes something. My favorite example is the 1860s when there was something called the Pony Express. It used to take mail from Missouri to San Francisco in 10 days on horseback. Okay? And the whole industry collapsed. There was a massive booming industry the moment telegraph was invented. Does it mean we shouldn't have done telegraph? No, not really. I think we have to actually retool ourselves in a different way. But everyone is capable of doing that, and that's the way to think about it. I know it's a policy level answer, but hopefully it conveys the complete picture.
The next one, so obviously there's a lot of players in this field today, established enterprises, startups. Who do you think will be the ultimate winners and losers in this space? Take a wild guess.
I'd like it to be us.
Other than Qualcomm.
I'd like it to be us, but actually, broadly speaking, there's a categorization of those who are in the business of providing platforms and tools to make it very easy to use. Ultimate objective is to make sure that AI is very easy to use in every kind of a use case that you can think of. So there is certainly a massive role for platform providers. Today, broadly speaking, you have those who create new models, and there's plenty of those. By the way, there's a certain trend line that's coming in with not just the models from, say, Anthropic or Salesforce or Meta or Microsoft or Google. So the combination of the Gemini family, the Llama family, the Phi Silica family, and the Cloud family. But in addition to this, different countries have their own models that are coming in as well. In fact, beginning to see trend lines of what we are calling as sovereign LLMs. So for example, in India, we just worked with someone, there's a model called Indic, there's someone working on Krutrim, which by the way is a Sanskrit phrase for artificial intelligence. I really like that one. There's like a lot of these models that are coming in, which have their own domain expertise. So there is a role for model creators. And once you go into, remember that most of the foundational models today are still based on public data. There's lots of data that is actually restricted. So these domain-specific models, there's, I think, role for that too. So there will be some winners in that space. That will continue to happen. In addition to that, what you're left with is the enterprises, which are the first movers who actually embrace AI in all its glory and then go from there onwards. So combination of model creators, platform providers, and those enterprises who are actually running with it, generating the use cases. I didn't pick the names though, except us.
We got it though. And so time for one last question. You talked about AI inferencing, and we are seeing that happening on the cloud, but also good use cases on the edge. So how do you envision this transition to inferencing? Is it moving more towards the edge, the cloud, or like it is, or it's going to be a hybrid going forward?
I think already the trend line is clear that inference is moving more and more towards the edge. Why? Just because we can. So on a smartphone today, the inference rates go all the way to 15 to 20 tokens per second, going up to 30 tokens per second in a laptop, which is pretty impressive compared to what we could do just about a couple of years back. So inference, that trend line is inevitable, going towards the edge. It'll always be complemented by what you can do in the cloud, make no mistake about it. But I think right now the trend line is inference moving more towards the edge, foundational model training remaining in the cloud, and somewhere in between we have fine-tuning with more additional data that comes in on top of it.
Cool. Very insightful. Durga, thank you so much
Sure.
for this talk.
Thanks, everyone.
Definitely set the pace for the rest of the day.
All right,
Thank you
thanks.
so much.
Thank you. Thank you so much. Thanks.